this is Nancy Wilkins Deere here in San Diego, and in my office with me, I've got PI Doug White, who's a professor emeritus at UC Irvine, and Paul Rodriguez here at SDSC, who's on the Gordon team. And you see from the slide that's being displayed that there are quite a long list of people who've been involved in the COSI Social Science Gateway. And it's an exciting project for a number of reasons. One is kind of the varied ECSS background for the folks who've worked on this. So Paul's done some interesting work. Bob Stinkovitz, who's not on the call today, but has also done some interesting work on this project from a computation standpoint. And then there's some really exciting gateway work that's been done. It originated with Tom Urim out at UChicago. He was on the ECSS team until fairly recently, and his work's been taken over by Lucas Lozinski, who's going to go through a really nice gateway demo for us first. I wanted to say a few words, too, about and Doug will say more about this, but the impact that this gateway is having on the field of computational anthropology, and kind of the widespread interest from Doug's community, the planned use in classrooms, incorporation into an online book that's coming out for Wiley. So this work is really paving the way in a lot of different directions, and we're really excited about it, which is why we have, such a large and varied team. So I'm especially pleased to have so many people able to come and present on a symposium today. So with that, Lucas is going to start things off for us, and he is sharing his desktop live. He's going to go through a demo of the gateway. Doug, I think, is going to jump in as needed with variable definitions and descriptions of kind of what's going on. But I think you'll get a very good feel from this presentation about really what the gateway is all about. So with that, Lucas, if you want to take over, that would be great.
Thank you, Nancy, for introduction. It's really exciting for me to work with Doug White, who is an anthropologist, and his research field is so far from IT because I work in computer science. So it's really exciting. I'm going to present work that was also in the session called Celebrating Ending Galton's Problem with Inferential Statistics and Galaxy Gateway in Society for Anthropological Sciences conference two months ago. And that work was, audience of this work was mostly anthropologists and sociologists, so there are not many technical details in this presentation that describe how all jobs are submitted to exit resources, etc. So if you would like to know more details, you can ask questions or reach me out after the meeting.
Right. Lucas, I think I'm going to mute the participant. There's some crackling that I'm hearing that I might be able to fix here. But yeah, folks can raise your hands via the web conference. There'll be a Q&A at the end, and there's also contact information for the presenters that's on the symposium website. So let me just do a mute here and see if that helps.
Presentation mode is now enabled.
Lucas, can you say something?
Hello, can you hear me?
Yeah, that's much better. Thanks. We'll go forward with that. Thanks.
So the COSI abbreviation in the topic stands for Complex Social Science Gateway, and this is the only gateway from among of 35 execute gateways that target social science. Within about 15 minutes, I'm going to present a motivation for building the gateway, how it works behind the scene, what the gateway offers for anthropologists and sociologists, what kind of tools they can use in the gateway. I'm also going to show you how to use it, run analysis, read results, rerun analysis with modified input parameters. I'm going to show how to share results with other scientists, other users of a gateway. And finally, I'm going to talk a little about features we are going to implement in the nearest feature. After 20 minutes of my presentation, Doug White will take over and talk more about science. Our goal was to create a gateway that supports researchers and students in running cross-cultural analysis without requiring them to understand underlying computational resources and how to use them. Even researchers who have access to and know how to use low-level tools might find such a gateway more effective, productive, and user-friendly, where all they have to do is to enter input parameters and submit a computational job. Then they can explicitly focus on the research domain instead of spending time on dealing with software and compute resources. Having such motivation, we looked for a software platform that would also be open source, supported by a big user community, easy to deploy from point of view of social science specific tools that we wanted to provide to users. We also looked for software where users can share histories, the analysis results with other users of a gateway, or even they can publish results and make accessible for whole internet users. So when they publish articles with results obtained using this gateway, they can point readers of articles to a URL on the gateway so they can see all results obtained for particular analysis and for see input parameters specified for this kind of analysis. All the requirements were matched by Galaxy, a platform developed by Penn State. Galaxy has been installed on a virtual machine at UCI. One or two virtual machines, each with 2 cores, were not able to run concurrently multiple jobs submitted by users at the same time. The number of jobs running concurrently were limited to 2 because the VM had only 2 CPU cores. Other jobs waited in a queue until one of the running jobs was finished. To remove a limitation, the gateway was configured to use stressless. Stressless is a cluster with 324 compute nodes, so it offered sufficient compute resources for jobs submitted to the gateway. The gateway is publicly available for everybody at the address http://sociecompute.ss.uci.edu. Users can choose which compute resource they want to use to run a job, UCI VMs or the Exit cluster stressless. However, stressless is recommended. Tools deployed in Galaxy and available in the gateway are in fact R scripts that accept series of input parameters and run cross-cultural analysis on one of the 5 different ethnological datasets. All the tools use DAO-if R workspace maintained by Anton If. After this introduction, I'm going to show you the gateway and how to run analysis. So Galaxy interface is organized with a menu on the top and 3 panes. The left pane with tools users can run, the right pane now empty with a history of all jobs and a status of currently running jobs, and the center pane where users can specify input parameters and see output results in a format generated by tools, for example, text, CSS, HTML, images, etc. The tools in the left pane are divided into 2 categories. The tools executed on UCI, virtual machines, they are displayed on the top, and the same tools but executed on stressless. The tools executed on stressless are under HPC tools link. The tools use different versions of DAO-if R workspace. the tool EA, LRB, SCCS, WNAI exposed directly use DEF01. Tools using newer versions of DAO-EVR workspaces are named DEF01C, 01D. We recommend to use DEF01D on Trustless, the newest version. The gateway can be used without signing in, but then job results are not stored and cannot be reviewed during the next session. So the gateway is publicly available for everybody, so everybody can go to this website and register to create an account. And when an account is created, a user can log in and run analysis. So I'm going to log in to show how to run jobs for different input parameters. I'm going to the HPC tools and taking DEF01D. At the center pane, we can now specify input parameters. I'm choosing the default SCCS database, and to make it faster, I'm going to copy parameters provided here as an example. So independent variables in unrestricted model, and I'm going to plot the 1260, which is total pathogen stress, and I'm going to submit the analysis. The analysis will generate 3 output files. We have a gray box for each output file on the right, and the boxes change color when the job is submitted. When job is running, the boxes change color to yellow. So now the job is running on Trustless remotely. All the input parameters are described in code books. We can find description of variables going to the main page, taking the link Visual Manual. Main page, Capon mtsu.edu, and codebook for SCCS. So we can find description of all variables that are described by numbers. We can find a description what the variables mean. So the job is still running. In the meantime, I can change a name of a history. So next time when I log in, I can identify the history easily by the name. So let's call it demo. And in the meantime, the job was finished. So I can see output of a job. Which is a HTML file with one image and also output in CVS format with all input parameters and output results. The job can be also submitted again. I can run this job again with different parameters. I can modify them a little bit to find what are output results for a little bit different models with different input variables, or I can submit completely different job, and I'm going to submit job for LRB and completely different input parameters. So I'm specifying dependent variables. All the variables as described in code books for LRB. I had a cheat sheet. I don't have this cheat sheet with me with a description of variables, so I cannot say what they mean. But Doug White might comment on that later, and I'm going to submit the job. So I'm going to plot all dependent variables. So we will get five maps, 5 plots. Let me enter the variables again. I'm not sure what was wrong. Okay, the job is submitted in the same history. In the meantime, I can create another history, new history to submit different analysis, so I can create different groups, different history for different type of analysis. And let's submit EA, ethnological atlas with its default variables, so we can see how we can create multiple histories. I'm going to look at all safe histories, so I can see that I have an unnamed history. I can change the name of this history, say EA demo, and refresh safe history. So I have 4 histories with 2 histories created recently, demo and EA demo. With jobs, I can see that we have 3 jobs finished. We have 3 other jobs running and other 3 jobs waiting in a queue to be submitted. The histories can be shared with other users. To share a history with other users, I'm going to the history menu, share or publish, and I can make a history accessible via link. So all users, not all people who know the link can see that analysis, that history of all results, or I can share the history with selected users. So, for example, I will share history with Douglas White, uci.edu, and I can also share history with another user. I have two accounts with lukasz@uchicago.edu. So the history is shared with only two users of the gateway. The LRB job is still running, so I'm going to log out and log in as another user to see if the history was shared. I'm going to log in as lukasz@uchicago.edu and check shared data, published histories. So I can see that so many histories were published and shared. With other users, and I can check which histories were shared with me. So EA demo was shared with me. I can view this demo, import the history, and if the job EA is finished, submitted and finished, I can see results and input parameters. Doug White can elaborate about what analysis were run, what kind of analysis can be run on this gateway from anthropological point of view. That was a touch of what the gateway can do, what features are offered. Thank you.
Lucas, great. That was terrific. Not often that I see a demo work on keys like that. So very good. Congratulations. Let me grab back. Okay, great. So we've got presentation control, and now we're going to continue with Doug. Yep.
Yep. Yeah. Let's go down in our slides. And that was wonderful. The problem you were having with EA is that the Graphic Atlas has about 1,400 societies, which is why it's slow. And the RLB is Robert Louis Binford. It's the famous forager database. He has a successor. Binford died about 10 years ago. The database has been completely reconstructed. So see my outline, and I'm going to move right along. You've seen that Lukasz has used the Irvine site called InterSci Wiki, and a lot of material can be accessed there, including access. He used that to get the code books. I'm going to move along through this outline. From a general point of view, I'll get to some specific examples. Software, we call it DEF. The small f in the name is for functions. This is not yet an R package, but this is a series of R functions. So it solves the great, enormous problem that anthropology and every other social science and every science that depends on observed variables. They are all riddled with autocorrelation. That is, you don't just get naturally observed observations out of the world that aren't clustered or autocorrelated. And this is the first major statistical package with other all SPSS, SAS, et cetera. None of them solve this problem. That really solves this problem and also gives you imputed values of missing variables. The solution then here is you're getting closer to the actual determinants of variation in the database, whether it's cross-cultural or whatever. It also, because it's an anthropological database, has deeply embedded data pertinent to evolutionary and economic processes. It has a great deal of ecological data that is not necessarily in the original codes, which are made by authors who have read hundreds or thousands of ethnographies in some cases. And we'll also have satellite data, GIS and so forth. And there is an interface between archaeology and ethnographic data that's in process. So the idea is, as a major science, we can understanding our present and future is greatly enhanced by understanding our past. So these databases and the DAOF functions are essential in integrating physical sciences, biological sciences, anthropological, historical, and other social sciences. This is just an example, not of a model, but of the diagnostics used for a model that are tremendously important. And here you see the stars mean some of these inferences had significant kinds of bias. One triple star there says you're not getting all the appropriate variables in this model. The key to solving autocorrelation is that the error terms in regression, you see on the right a double star. The residuals here are kind of clustered more or less randomly. It's called heteroscedasticity, and they're not normal. In other words, this is probably not a great model, although it is predicting 53% of the variances. So the weaknesses here are the number 1 and 2 below that I've mentioned by name here. All other statisticians who develop these tests. I'm going to give you an example. So here we'll see some named variables. In this case, the variable is avoidance, and kinship avoidance is very commonly found in about 1/3 of all the societies in these samples. As we'll see, it occurs mostly in the lower range of complexity. And previously, up to now really, from the 19th century to the 20th century with George Murdoch, anthropologists thought that avoidances were easily explained by the fact that if you go to live with your wife's family, you're more likely to avoid her mother. So this is the Texas avoidance theory. There's no basis for this, in fact, nor is there any basis for the opposite idea. If you go and live with your husband's family, you're more likely to avoid his father. The cross-sex link there being supposedly a difficult psychological problem, where there's no evidence. We have 2 data sets that have these codes on avoidances. There's no evidence that either of these are true. Graduate student at Irvine, Tolga Ostan, and myself used this for both a world database and a regional database, which is very interesting because why should you get the same answer in a region of the world as you get in a world sample? Well, actually, we find evidence of this. And the model using DEF predicts that what's happening here is if you marry into a set of new in-laws, not old ones, not people that you're already kin, with, but new in-laws, what the prediction is that when avoidance occurs, you're getting broader, the effect or the determinant, whichever way you want to look at it, the prediction of broader networks of cooperative behavior. And these are networks in which the avoidance relations are not conflict relations, they're actually alliance relations. These also affect, in the DEF models, the expansion of political alliances and increase in population science and the sizes. And the discovery here is that kin behavior, particularly avoidances, are a key source of development of cooperative ties in foragers. And then this kind of trickles out as you get more advanced societies, other forms of political organization cooperation start to occur. The reason I'm picking this is because one of the things that we see here in where the yellow arrows are is the autocorrelation effects for each of these types of avoidance. Wife's mother at the top, column 2, wife's father, column 3. Husband's father, that's a same-sex relations, less common. It's column 4, wife's mother, another same-sex. And then there's about 25 other avoidances, one of which, a very common one, is wife's brother's wife. And that occurs when brothers avoid their sisters, which means, hey, there's something funny going on here. We have an article on that. I won't talk about it now, but I will say that if you look at the yellow arrows, the most common avoidance, wife's mother, has autocorrelation through language. What that means is that some set of similar origin societies having the same language were the inventors of wife's mother avoidance. The next avoidance, wife's father, is found in different ecologies. So what that says, and it's almost a subset of wife's mother, which says, okay, then this invention was changed and adapted to a new ecology where the cooperation from the husband to the father was more important. And then after those two steps of evolution, in a probable evolutionary sequence, and we'll get to time series later, after that it's just distance diffusion. So you learn something here from the autocorrelation coefficients about evolutionary process through time, even though we haven't yet looked at the temporal dimension. Here's a little more on that topic. It's supported by the cross standard sample of the world, SCCS, and it's supported by the North American data, which means the same kinds of processes with slightly different variables, because the variables have to be extrapolated from one context to another. But the same kind of evidence for this theory is backed up regionally as well as worldwide. And we take the decline, there's a spurt of growth with avoidances in complexity, and then suddenly it's a level where it's competing with complex political structure, and it starts to decline. We don't see anything but Texas avoidances, which are just totally something else. Texas mother-in-law stuff. That's the modern interpretation, or there's all this Freudian stuff. None of the Freudian models stand up. Matrilineality is also a factor here because it creates men who are distributed with their wives and form very powerful alliance and defense groups. We do have some kinship in there. And in general, the avoidances are based on respect, not fear, and gift-giving allows you to release your mother-in-law avoidance. Hey, we're friends now, we've been together for a while. And all of these lead into the study of cohesiveness, which is the next topic that I want to look at, because we're looking at measures of cohesiveness in the database. There's a whole 109 case database in Paris that consists of researchers on kinship, and the data are networks, and there are measures of cohesion. cohesion. I haven't included it, but it will eventually be in this database, all of those cases. We went up to the unsolved problem, that problem we consider solved but not present here yet. I have an ethnographer listening named Woody Denham who does this kind of network analysis in Australia. He's in our audience. And here we're going to the really hard problem, an unused theorem, unused from 1934 to about 10 years ago when we started working on this problem. And that is the most powerful measure in my mind because it's highly predictive in network theory is the Menger theorem that there's an equivalence that we call structural cohesion of how many paths do you have connecting one another in a group and how hard is it to separate the group by removing members. Those measures were proven to be precisely equivalent. They are the strongest and most predictive measure that we have in network theory. All this is still just starting to be used. So let's, you can predict things of a very large and complex nature. And here are some slides from Bob Sinkwitz, who's working in Gordon over at SDSC. And these are some of the models of ways he's approaching the solution to this problem. The problem has been solved following our work, which has been in press for 10 years. There is an existing program independent of our work, but it builds on everything that we wrote about. Frank Harari, the graph theoretician, in mind. So we're trying to go the next step and isolate structurally cohesive groups. And one of the things that you can do is count for any two people in a network, like a kinship network. Olga Ostan, who's working with these kinship databases, is looking at, well, any two people in a kinship network may have a single path of connection. They're in some ways affine or kin, or there may be multiple paths, and this is a matrix of multiple paths in a small. We use that in doing the solution to the larger problem. So I'll move on there, and hopefully I can get to the end of my slides here. And these are the magnitudes of things. We're looking at co-author data set with 128,000 people, so that is a problem that has never been solved before, and we're honing it down to subnetworks. This is all the sociology journals from 1963 to 1999, studied by one of my co-authors after authoring with Frank Harari. I co-authored with James Moody, and we developed the first model, which is now in iGraph, one of the standard network software packages. So here is Bob showing us diagrams that are cut sets between large cohesive networks, and I won't do the details, but you'll see more about that later. And as he says, and in his next slide, this is not quite done, but they're a step in the right direction, and we have candidates that make the problems. We are getting closer and closer to finding the true K-connected subsets, and there may be thousands of these with different strengths. The strength of a K-connected set is how many people do you have to eliminate? Maybe 100, have 100 cohesiveness, all independent channels, and that means there are at least 100 independent channels between every pair of people there. Now the object here in red, using high-performance computing, is to be able to move from the small-scale networks that we look at as anthropologists to the large-scale anthropology at the level of large-scale networks like the internet and all kinds of other things. Future work. Okay, this so far has just been a discussion of things we've done already, and that can be done through I call it COSI, you call it...
I probably mispronounced it.
No, I like your pronunciation better. COSI.
Yeah.
COSI. COSI, COSI. Take your preference. I'm starting to like COSI because we got cooperative sciences here. Okay, so we've seen that, and the DEF1, A, B, C, D are things that have been implemented by Tom Urim and Lukasz Liczynski that we've heard about. Now, what we've done, this new work, the middle paragraph says, okay, I go to Paul Rodriguez, who's at SCSD as a user consultant, and I say, look, what I want to do is take the imputed data out of all these databases. In other words, the data had holes. We patched the holes. That's what DAO-F did. Now let's take all those variables, forget about modeling some form of regression with autocorrelation, and just look at the structure. Although usually our variables are clustered around a topic. In this case, we're going to look at the variable high gods. And just this year, 2014, there came a new R library. Ours are not our libraries as yet, called BNLearn, Bayesian Network Learning. And we put that on Paul. I found it. Paul and I read it, the book and the data about the package, and he put it on trestles, and with 6 commands, we had to recode some of the variables to make them have names rather than numbers, because we're at the point we want to see the names, okay? And so we're going to see names on these variables. And with 6 lines of code, boom, we found a what's called a Bayesian causal network. It's not necessarily causal, because to be causal, you have to have a prior theory that's being validated, but it's suggestive of potentially causal relations. And we'll see that next, but I want, before we go there, which will basically end the examples, we are looking at being able to use trestles this way, or trestless, whatever we want to call it. What do we call it?
Trestles.
Trestles, okay.
Sorry, Lucas.
There's a second round that we're proposing to take everything we've learned in these 2 years and put it now in a whole context where, instead of using local computers that can feed into trestles, but takes 20 minutes for one run. If you want to do iterations, you'll be there all day. Here we have the use of high performance computing trestles, because we're going to look at hundreds of variables at once. And in the second year, we're also proposing undertaking time series, Aki information criteria, multivariate models, path analysis with imputed variables, using these same strategies. So now we'll go to Paul's work. This is, you're right here, Paul.
Yeah. Okay, so as Doug was saying, he was trying to look beyond OLS, and I have to say it was a happy accident that Doug came to one of our summer institutes, I think, and he saw some stuff I was doing with some genomic data. And so he came to me, and we started chatting and going through different other possibilities, and came upon, and Doug did a lot of the work, a lot of conceptualizing, and I think a lot of this whole endeavor wouldn't be so successful without Doug's foresight and vision. So, having said that, we settled on this particular method, Bayesian network. We found this package, as Doug said, BNLearn. The basic idea, and I just want to give you the basic flavor. You're interested in your variables and the joint probability over all configurations of the variables. You go out and collect frequency counts for all the variables, and you kind of you're building a graph essentially, and the graph determines how the probability of some variable depends on other variables, instead of depending on all the variables at once. So the structure of your graph is, in a sense, determining the probability tables. So in the particular example we're looking at high God, family, and community wages intersection, I believe, interactions, animal and
Rain.
And
rainfall.
and rainfall, a couple other variables. We can talk about those more later. And just to give you, again, the general sense here is that if you're interested in something like high God as a function of other variables, you're trying to find structure in your data that lets you say high God only depends on, let's say, one of the variables or some subset of the variables. And the basic idea is you have to, you're basically doing a fit of a model on data. That fit depends on what structure you have determined in your network, whether it's, and you can measure these things locally or globally. There's a couple different ways to find a structure. The greedy search or hill climbing are kind of the two sort of big categories of ways to do it, but there's some variations. And essentially the problem here is that you have many solutions that are possible with the same fit. So borrowing from what people have done in biological networks, we took our bean-learn package and we added a bootstrapping procedure on top of that. So not only do we find one network structure that has a good fit, with bootstrap samples we can repeat this over and over again for different subsamples, resamples, and come up with a whole set of networks and then average across networks.
So we have to justify either building a user community to continue our work and get the type of support in ECSS, or train our people very quickly in our social science fields to be able to run these sites. We're having a bad time at that, but we're trying to get another. It's very difficult to ever get another ECSS. But this is what we want to do. Now, this example, I'm testing the HiGOTS model, which is in the upper left, with another model. Unfortunately, it's one of Anton Afton's students. So Anton, but his model doesn't work. So there are some crosstabs, and you can see how HiGOT 1, 2, 3, 4, 4 is the HiGOT, is associated. They can be Islamic, Christianity, or other, about 10 other societies. But here we see at the top that if you're an animal, if you're a pastoral society, high level of pastoralism, 1 to 9, 0 to 9, and in that case we'll usually have camel and horses, and you'll be running goods across the link, the silk trade links, which are numerous between China, let's say, and Constantinople or Istanbul. I was just there, so about that. There are two predicted variables. One is you've got this animal-based trading system which is unstable, because if you're also buying called bride wealthing or bride price, if you're using your cattle and horse wealth to but acquire through traditional means a lot of wives, you're going to be very well off, because you'll have the reproduction and you'll also have the capital producing requirements for what? For instability, my friends. Okay, that's what happens. But the stable of instability in pastoral societies is rather like that in commercial economies that have exchange systems. I won't show you that, but that's what having fixed FX community wages, fixed communities with wages, they have the same instability that comes out of holding property and being at an advantage when there's excess population, scarcity. Since you have excess population, the wages are down. The instability is structural. I won't go further into that. That's the model, but two models there that we saw work in both cases, and none of the other models do. Okay, we'll get back to Paul here.
So just to show you what some of the output looks like, this is the graph here shows frequency counts for particular networks across the 1,000 bootstrap resamples. So remember, each resample of your data, sampling risk replacement, you run a BN learn, you pull out a network, convert it to a string representation, sort them and count them, and And so two networks stand out as the most frequent. And so this is, again, referring to the variables that Doug was just mentioning. These are the main motifs that come out of this. And there's a library, it's called the Bootstrap library. Here are some of the other functions we're using in the R package. Plotting was done with this rgraph viz package. And so you see the difference here between the two most popular graphs. One of them, the no rain and the writing are interdependent, but in the other graph, the no rain is moderated by or mediated by animal wealth for its effect on high God, or the writing is disconnected. And then if you just average across, so these are particular networks, and we can also average across all networks, and you get a picture like this. So this is, in a sense, giving us an expectation of whether or not there's a connection or an edge between these particular variables. So again, you see the two variables that Doug mentioned as being probably most important, having an effect on high God, and you see that the no rain dry variable is mediated by animal wealth. And then you see some other connections that are possible, but not nearly as strong. So we get this. So it's nice. We get the probabilistic picture.
So we want to do this kind of thing at a larger scale using additional software on vessels for the next couple of years, develop the software, and then be able to do large-scale models of what's happening in human systems generally. Everything we know archaeologically, ethnographically, different samples, different databases. See, we've got 600 variables here. But this is my favorite slide. This says what are the significances of those variables after computing the data and doing autocorrelation controls. Well, I'm not showing the R-squared here, but it's quite high, and there are a lot of significant variables. So the question is there a Galton's problem? Well, let's just do the same model in OLS without any controls for autocorrelation. Do you see much significance there? And in fact, the R-squared, no.
So you've seen, significantly different results.
Right, yeah. So this is not pie in the sky. This is not an artificial problem. This has been denied backwards and forwards and up and down in every one of the sciences. I don't just mean social sciences. This kind of software ought to be used in all of the observational sciences, up and down the line. We have left 10 minutes for discussion.
What a good note to end on. Let me go ahead and unmute the phone lines here.
Presentation mode is now disabled.
Okay, great. First, does anyone on the call have questions for Lucas or Doug or Paul? I think it's really fascinating work, and what's interesting to me is that through the gateway now, so many anthropologists can have access to these codes, all these R routines, all the porting work that you've done to get going on supercomputers, the large databases, and to kind of put that power in the hands of really anyone. I mean, to me, it's tremendously changing for the field. I think you could say something about some of the reaction that you've seen in your field to this work.
Well, just last week, Dean here and key players in the leading technology departments in the U.S. said they're so excited about this of logical science that they wanted to have a little second celebration, invite a bunch of people to their university. I don't want to interfere with their process of decision making, but it's also a group that's close to Amber Johnson, who is the person we were looking at with the RLP database, the famous Binford database, which everybody has looked at. We haven't had any access to it because Binford died. Johnson, she was his student, now teaching nearby. getting. The Center for Computational Anthropology in England has completely remobilized how we use text data as data entry into, there's a lot of reading of ethnographies and coding variables going on here. We started the standard sample to do that in 1969, published names, locations, and times where there were the good ethnographies one another. But it turned out in that very article, I wrote part of the article that said, hey, don't kid yourself. We did tests of autocorrelation. There was not any of our test variables. The effective N got down to 10 societies might be considered at most to be independent. And others went all the way up to 25. So what can you do with 25 independent cases? Not much. You can now. And I think this problem has been so well recognized in anthropology that many anthropologists put down comparative research as invalid. Well, my friends, there are now valid studies. And we now have coursework and have had courses where you can teach anyone from a high school student to your postdoc, and of course the researchers themselves, and use this software, and it has been used and tested in courses, and there are ones to go with it. I think that's going to be it.
Yeah, very, very exciting work, Doug. I mean, I think what we in ECSS are all about is kind of taking the science in some new direction because of the application of high-end fiber infrastructure, and so it's exactly these kinds of cases that get us excited. Sergio Sani-Levitt, who leads Succeed's Novel and Innovative Projects team, is on vacation. Otherwise, I'm sure he would be on this call and would be thrilled about this. So, he can listen to the recording and catch up later. Yeah, the YouTube will be up on the main symposium website, and there's also contact information for Doug and for Lucas, and we'll get calls up there too. So if people have questions afterwards, they can contact the presenter.
We'll post this PDF or PowerPoint.
PowerPoints will be up also. Yep. Yep, I can do that. Yep. Yeah, so any comments from anyone else on the call?
Nancy?
Yeah, is that Suresh?
No, this is Sudhakar.
Oh, Sudhakar, great.
So is there, I'm just wondering if these methods are used for any of the simulated data that is generated? I mean, I know we know that, for molecular dynamics, there's a lot of, autocorrelation that we look at for, atoms moving together or, groups changing and so on and so forth. But, other simulated data in social science.
Let me make a preparatory comment. Malcolm Dow and I, he was my graduate student, he's now emeritus like me, but we did a simulation study about 25 years ago, and we found that in simulated data, varying amounts of autocorrelation. Autocorrelation very quickly came to wipe out 50% of all the valid from such data. Now, obviously, this is all open to new simulations. We went for the solution rather than more simulations because it was so strong that most of our literature is highly contaminated with spurious results. Everybody knows it. But we're open. All you need is a database, and if you want to put missing data in it, that's fine. The system will take care of it. So you compute only a few autocorrelation variables like distance, in our case language, but you only need about 3 or 4 of these things to get rid of the autocorrelation effect, that is, to approximate our IID errors in the error terms. But it's not hard to do and to test out different. Now, Antoneff, and there are about 35 articles by these two, Dow and F. They're on the site, all of their bibliography, where they solve each one of the successive problems. So we're totally open. I mean, it's an open site. You can arrange to upload data and use the software for the adults analyzing data. So we're totally open. We're an open science. I mean, we're not. This is a Creative Commons NC, that's non-commercial. No charge, and I don't want anybody building a business on this because we'll sue. I really believe in open science.
You know, it's interesting that Sudhakar is a computational chemist at NCSA, and so that he sees the autocorrelation problems in his field also. So it's sort of interesting the overlap in fields and the relationships. I think at this point we're at the top of the hour, and so I'd like to be respectful of people's time and thank everyone for taking the time to join this month's symposium, and thank especially Lucas and Doug and Paul for putting a significant amount of time into preparation for this event. So thank you very much, everyone. We'll see you next month for the next symposium.
Thank you.
Yep. Bye.
Thank you.